All right, 11.5 is angle relationships in circles. Find the measures of angles formed by lines that intersect circles. Use angle measures to solve problems. All right, so here's your theorem. Go ahead and copy this down. This is going to be the exact same thing as the inscribed angle theorem. So when we saw it like this, and to get this angle, we took half of this. You're going to do the same thing. It just looks a little different, so they make it a different theorem. To find the red angle, you take half the arc. To find the blue arc, you would double the angle. So that's basically all you have to do. All right, so let's find the measure of angle EFH. So again, there's a lot going on here. Some things we need, some things we don't need. So first I need to find EFH. EFH is this angle right here. So I know from the last theorem, to find this angle, I just take half the arc that it touches. So the arc starts here at this point and it goes all the way over here. So the measure of angle EFH is going to equal half of FH arc. And that is 130. So the measure of angle EFH is 65 degrees. All right, now they want us to find the arc of GF. So notice GF, since they just used 2, it has to be this minor arc. It's not this one over here. If it was this, they would call it FHG or GHF arc. But since it's just GF arc, it's this angle right here, or arc right here. So I know since I have this arc, to find this arc, I need to double this angle. But notice they don't give me this angle. They only give me the outside angle. Well, I can find this because I know from my first quarter geometry that this angle right here is, and this angle here is going to equal 180. So I need this to be, let's call this x right now, x plus 122 equals 180. So to find what this is, I just subtract 122. And instead of x, I'm going to write 58 degrees. All right, so that's the measure of that angle. Now all I have to do is zoom out, and now I've got this angle is 58. So to find this arc, all I have to do is double it, because the theorem tells me that an angle is half the arc. So since 58 is my angle, and I'm looking for the arc, I just put it in all like this. To get rid of the 1/2, I multiply 2 over 1. Multiply 2 over 1 over here. And I get, arc FG equals 116 degrees. All right, next theorem. This one we're going to call the plus theorem, because there's going to be one where we minus it and one where we plus, and this is obviously the plus one. The way that you're going to remember this one when you plus and when you subtract is that if you look kind of at this, what's going on here, is that there's kind of a plus sign being made with these two lines. So you can think of this as being the plus one. All right, so if two secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arc. So basically what it's saying is this red angle equals the blue arc plus this blue arc divided by 2. So to find this, I'm going to set blue plus blue divided by 2. Red angle equals blue plus blue divided by 2. Now, the easy way to do this is when they give us these arcs. Well, sometimes they're going to give us only one arc and they're going to give us this angle, and we have to find this one. We're just going to plug in the information here and here and then try to solve for this one. All right, so let's find the measure of arc AEB. So first let's trace it out where AEB is. AEB is right here. So we're trying to find this angle. I've given this blue arc and this blue arc. All right, so the theorem tells me that measure of angle AEB equals half of the two arcs together, combined together. All right, so I get 139 plus 113 gives me 252. Then I take half of that, so I get the measure of angle AEB equals 126 degrees. All right, next theorem. This is where we subtract. So this is the subtraction theorem. Okay, this is if a tangent and a secant, two tangents or two secants intersect in the exterior of a circle, then the measure of the angle formed is half the difference of the measure of its intercepted arcs. So what you're going to do on this one is notice the three different cases. Here it's a secant, it goes all the way through, and this one touches the circle. This one, they both touch the circle, and this one, they go through the circle. So here, you're going to do the exact same thing each time, though. So that's what's nice, is it's different scenarios. They look different, but you're going to do the exact same thing. You take half, 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 and you're subtracting the big arc minus the little one, the big one minus the little one, the big one minus the little one. It's always the one opposite of the angle. Since the angle's over here, you take this one, subtract this one. This one, subtract this. This, subtract this. All right, so let's do this. To find A, let's work with A first. We're given this arc and this arc. This 7 degrees is this little bit of arc right here. We're going to be finding the degree of this angle right here. So I know angle X equals half something minus something. Well, the first something is going to be the opposite arc. So I have 87 minus 7. 1/2 87 minus 7 is 80. So angle X equals 40 degrees. All right, now over here, you're going to do the same thing. It's a little easier to see because it's not so zoomed in. Angle X is going to be half the big arc minus the smaller one. All right, so this becomes 1/2 126, and B becomes 63. So angle X becomes 63 degrees. All right, so this is a little story problem. If you want to be a super sciencey person, 2 of the 6 muscles that control eye movement are attached to the eyeball and intersect behind the eye. If the measure of arc AEB equals 225 degrees, what is the measure of angle ACB? So notice in your diagram, they don't give you a single bit of information, but don't worry, you're so smart, you can figure it out. So AEB, this angle, they're telling you this arc right here is 225, so I can just simply write that in as 225. Now, how do I figure out this one of the other two? I'm looking for this answer, I'm looking for this angle, but how can I find this? Well, I know from here, starting here, going all the way around here, this is going to be 360 degrees. So here to here, I've made up 225. I need 135 more to make up this, or 360 minus 225. That's how you get 135. So I'm going to zoom in and write in 135 degrees. Over here is going to be our x degrees. All right, so again, it's just reading the problem, making sense of it, and then just putting it in the equation. So angle X equals half the big arc minus the small arc. Equals 1/2 90. So the measure of angle X equals 45 degrees. All right, for this one, this is kind of just a summing up of all the things that you just learned. So here's what we learned last section. The inscribed angle, you just take half of it. This is what you did last section too, or no, was it this section? I can't remember. It was this section. It's the same thing. You just take half. These are all they're telling you. All of these ones, you just take half of it. This one, you add them and divide by 2. These ones, you subtract them and divide by 2. So copy this table down, and it'll be kind of a good reminder, highlight it, memorize it. know when you add and when you subtract and when you just take the half of it. All of these you're going to take half of it. It's just a matter of, are you just taking half? Are you adding and then taking half? Or do you subtract and then take half? All right, so example 5, you're going to be using a combination of pretty much all of these. How fun is that going to be? All right, this is going to be your last example. And we want to find the measure of angle arc YZ. So here's YZ. And I need to find it. How am I going to do that? Well, I'm probably going to have to start off by finding little bits of information while I go along. So I'm going to, step 1, they're going to say find UY. Well, they want me to find this arc. How is that going to help me? Well, to find this one, I can see I've got this angle and I've got one of the arcs, so I can find the big arc. But how am I going to find this one? Well, let's zoom in and see if I can fill in anything I know. Well, I do see this little linear pair going on here, so that's nice, because I know from here all the way over to here is going to be 180. And so since this is 113, I need this to be 67 to make up 180. So I put in a little 67 here. Well, now I see this makes kind of the plus sign angle here. So to find this angle, I would have taken this plus this and divided by 2. So I know that angle WVZ equals 1/2 of UY arc plus WZ arc. Well, angle WVZ is 67. UY, I don't know. I want to try to find that out. And WZ was 68. All right, so now I'm going to solve for this. I'm going to multiply both sides by 2 to get rid of this guy. This becomes 134 over here. Now I'm going to subtract 68, and so UY, arc UY, becomes 66. All right, so let me zoom back in and add this information. All right, so that's going to be pretty helpful, because now I want to find this one. And I know if I had this one, to find this angle, I would take half of this minus this and take half of it. So I know angle X equals 1/2 of YZ arc minus UY arc. Because this is on the outside, so I take the big arc minus the little arc. Well, I don't have the big arc, so I'm going to sub in everything else except for that. I know X is 49. The 1/2 stays 1/2. I'm looking for YZ, and I have UY is now 66. So I'm almost there. Multiply everything by 2. This becomes 98. Add the 66 over. And I get YZ equals 164. Ta-da! We did all that fun work in order to find the answer, and they didn't even give me but one piece of information. So again, these type of problems you're going to have to figure out, all right, what can I start with? Where do I need to end? So based on where do I start, what kind of things can I figure out? I've got vertical angles, linear pairs. I can find arcs now. I know all of this cool, fun information. So you've got to figure out what you know and how you know it, and what else can you know because of what you know.